So we said in the previous video that the Tableaux method is a way to check whether a given set is satisfiable. Given this connection between logical consequence and satisfiability, all we need to check to know whether delta is a logical consequence of gamma is to check whether this set, the gamma plus the negation of the deltas, is or not satisfiable, right? Okay, so our tree will start with a list of formulas, right? We have to place the gammas in the first place and then the negation of the deltas in the second place, right? And the three rules in order to extend the tree are like a systematic way to search for an interpretation making through all the formulas in this initial list, right? So the three rules can be read from the truth conditions of each logical connected, right? So for example, suppose that we've got a formula of the form A conjunction B in the tree, right? In order to analyze this formula, we have to extend the tree with two new formulas in the same branch, right? A and B. Why? Because there is just one case in which A conjunction B is true, namely the case where both A and B are true, right? That's why we don't have to consider just, we have to put both formulas in the same branch, right? Because there is just one case in which a formula of the form A conjunction B is true, right? Now, a different case is that of the negation of a conjunction, right? So a conjunction is false in three cases, right? When either one of the conjuncts is false, when the other is false, or when both are false, right? So there are three cases where the negation of a conjunction is true, right? The case where one of the conjuncts is false, and the case where the other conjunct is false, and the case where both are false, right? So our tree rule will have to cover all the possibilities, right? That's why when we've got the negation of a conjunction, our tree will open a branch, right? So we will consider in a separate way what happens when one of the conjuncts is false, and that's why we write negation of A, and we will consider what happens when the other one is false, right? In this way, we make sure that we search for all the possibilities, right? All the other three rules work in a similar way, right? So we will say that a branch of the tree is closed whenever it contains a formula and its negation, right? When a branch closes, the tree is telling us that this attempt to find an interpretation doesn't work, right? Now, a tree closes whenever all its branches are closed, right? If the tree closes, then this means that the initial set of formulas is not satisfiable, right? Now, it might happen that some branches close, some others don't, but you have applied all the rules to the formulas that appear in the tree, right? So there is nothing left to chop, right? Or nothing left to analyze. In that case, the tree is open, and it's telling us that there is an interpretation satisfying the initial set of formulas. So in order to make these things more clear, more precise, we're going to make an example right now.